All right, so you should have done some reading, found this definition of a parabola. Parabola is a little bit more than just y equals x squared, isn't it? You should have also seen a diagram, which we're going to actually create. So if this is still blank, that is fine. And maybe you filled in a little bit of the formula. We are going to definitely explain the formula. But if you at least filled it in, you're starting to get an idea of what is known as a conic section. Now, let's see if we can create a parabola that basically follows this equidistant definition. In other words, what really is a directrix? What's a focus? And what's a vertex? Well, I have a feeling that you probably have an idea what the vertex is, but we're going to find out that really a parabola is defined by a directrix, which ends up being a line, and defined by a focus. Now, the important thing to realize here is that the directrix and the focus could be anywhere. That's honestly what makes the parabolas different and makes the equations different. So don't worry too much about why I drew the directrix right here. We just need a line so we can start. We also need a distance, and I'm going to do a little activity here if you want to play along. We're going to try to do this differently depending on if you're a boy or girl. Had we been in class, then you would be able to compare your two answers. We'll see if we can figure that out. So I'm going to go ahead with the boy version here. Let's say that we want to find a vertex that is midway between a focus and directrix. Now, if you're saying, what is that? Well, just measure a 1/2 inch from your directrix. Now, girls, if it's if you're a girl, then use a full inch. But what we want to do is we want to measure a distance here. Now, just pretend that I'm measuring again a 1/2 inch. So I'm going to put that down. That's going to make my first value here, which again ends up being the vertex. Now, I got to get used to this technology here. We also then are going to have a focus, which is going to end up being the same distance from this vertex. So we'll make that another 1/2 inch. And again, if you're a girl, you can be using a different measurement here if you want. But the main thing I want you to realize is we're starting to get our terminology down, and that is that we have a we have a vertex that is between the focus and directrix. Do you see how that works? We have a vertex that's between the focus and the directrix. Now, the parabola ends up being all the points that are going to be equidistant between this focus and this directrix. What does that mean? How can we have points that are equal distance? Well, what we have to do is we have to start to basically find some distances. And when we say find, we realize that these distances really can be any distance, as it's going to change. Let me show you. Here's a point. You might say, well, how'd you come up with that? Well, let's see if that point is the same distance from my directrix. Now, whatever that distance might be, you can measure it, and then you want to take your ruler, and you want to see if this distance right here ends up being the same. Okay, now for the sake of what I'm trying to show you in this illustration, let's say that they are. So we have a blue point that is the same distance. Maybe I'll call that distance right now D1, and this distance here being the same is also D1. And so maybe showing it with like a dashed line, these two distances are the same. Whatever measurement that came out to be, maybe it was like an inch, maybe it was 3/4 of an inch, but the point is that those two distances are equal. Now, could we find another point? Sure we can. What you want to realize is that it needs to be equal distance from the focus and the directrix. Now, where could that point be? I don't know, maybe it's right here. Now, again, students say, well, how'd you get that point? I don't really know if it's the point yet until I measure. So what I want to do is I want to measure this distance from this point that I came up with to my directrix. So, whatever that distance is. I don't know, again, maybe it's 1.5 inches. It depends on the size you're making this. But we'll take that distance and we'll compare it with this distance right here. And, well, we're hoping that they're the same. Now, it looks like just even on my screen here that they're not the same. It looks like that my blue point should move a little bit. It looks like maybe it should move a little more like this. And that's actually what you end up doing. You end up kind of adjusting your point that you honestly just kind of guessed in the first place to see if it ends up being the same. And so maybe now this distance here, we'll mark it with this dashed line. We'll mark it with this dashed line is the same as this distance over here. And we're going to pretend that it is, so that this blue point ends up being another point that's on my parabola. See if you can find some more points. I'm just trying to get you to understand the definition of a parabola, and that is that it's going to end up being points that are equal distance from the directrix and the focus. At this time, I encourage you to keep measuring. Maybe you would locate another point around here. Ideally, I measure it. It looks like that the one that I plotted there is a little too close to the focus, so maybe I got to scooch it over here a little. And now my two distances are probably more equal. The reality here is that the points that I plotted could be plotted in a symmetrical manner on the other side. I certainly could and should measure them. And again, keep in mind that these dashed line measurements would be equal. And look what you get. Well, a parabola. You get a parabola. Okay, you might say that's a lot of work. Well, that's technically the definition of a parabola, where all of these points on this parabola are going to be equal distance from a focus and a directrix. And what this really implies when we get into a little bit more of the physics of this math is that this focus right here is a special point. It literally is the place where all the values would reflect to that center. And that's why when we talk about a reflector, like a satellite dish or a mirror that's used in telescopes, that anytime a light ray or a signal comes from like a satellite, it always bounces to the focus. Whenever you have a perfect parabola, you always get this reflection, this bouncing effect. And the focus, honestly, is the antenna. It's the antenna of a satellite. It's also the place that captures the image, the lens, we would say, for like a reflector, like a mirror or a telescope object. So, what would happen if you were making a parabola of a different size? In other words, a parabola where this measurement, maybe that we took initially as being a guy versus a girl, was different. What if my vertex and focus were here? What if this distance was bigger? And by the way, the distance that I'm referring to here in a moment is going to be defined by a special value. I'm going to go ahead and preview it with you. It's going to be defined as the letter P. The letter P is always going to be this distance from the directrix to the vertex, or from the vertex to the focus. So it's an important measurement. It's the letter P. But just for a moment, I want to say to you, what if it had been bigger? What would our parabola have looked like? Well, it's hard to compare unless you're sitting with a friend right now, which you shouldn't be. But what would have happened is our points would have felt wider. Our distance that we would have had to measure would have been bigger. And so this dashed line distance to create these points would have caused us to have a different shaped parabola. What's the word I'm looking for? A dilation. And so as the letter P changes, as that distance gets bigger or smaller between the directrix and the vertex, or between the vertex and the focus, we end up with a different shaped, a different dilated parabola. And so ultimately, these are the things that make all parabolas. All right, well, I hope you saw that this p-value, it's pretty important to the parabola. In fact, it's something I'm going to encourage you to add to your little box of notes here, where we can say that p is this distance, did you notice, between the directrix and the vertex, or the vertex and the focus. So this p-value, which can change, is actually it is part of your formula, and I'm sure you've seen it in here, but let's make a little bit more sense. Let's make a little more sense of this formula. There's a few other things that I want you to notice. First off, there's definitely a vertex that plays a big role in your formula. Notice that h, the x value, is always with x, and notice that k, the y value, is always with y. And that's happening in both of our formulas. Even if y is on the other side, it's always k that's with y, and it's always h that's with x. The other thing that I want you to notice here about this formula is which variable is being squared. And when x is being squared, when x is being squared, we're going to end up with a vertical axis. We're going to end up with a vertical parabola. But when it's y that's being squared, then we're going to end up with a horizontal parabola. What exactly do we mean here? Take a look at this somewhat more finalized version of these notes, where I definitely want you to see that the variable that's being squared is going to relate to the direction of your parabola. And the other thing that I want you to notice here is that the direction of your parabola is going to depend on a positive or negative p-value. You see, if I have a parabola that's going to open up, well, that's always going to happen when I have a positive p-value. And I would encourage you to draw a parabola that's opening up, because I want you to see how the focus is on the inside of the parabola, and the directrix is on the outside, specifically one being above the other. But when our parabola opens down with a negative p-value, that's going to change the positioning of our directrix and focus. So here, notice that the focus, it's still on the inside, but of course now it's under the directrix, which is still on the outside. That's for a vertical parabola. Again, a vertical parabola is when x is being squared. But when y is being squared, that's when we end up with a horizontal parabola. So what's a horizontal parabola going to look like? Well, I encourage you to draw a sketch, because if p is positive, your parabola is going to open to the right. Notice that the focus is on the inside, but the directrix on the outside is to the left of this. And just the opposite, if I have a negative p-value, then my parabola is going to open to the left. Again, focus on the inside, directrix on the outside. All right, so let's flip the paper over and dig a little deeper into starting to use these equations. We find out that the first thing we want to do is try to write an equation. And I really like to use a visual approach on these problems, and I find that students do also, because as soon as you start sketching some things that are easily determined here to be true, like that your vertex, of course, it's given to you that it's at 0, 2. But compared to the focus given to you at 0, 5, as soon as you start to sketch these things, you really start to see all kinds of things that are true about this parabola. I mean, one thing that is true is that that would cause the directrix to have to be down here. It would also be true that we have a p-value. That's going to be a very important number, so we might as well find it now and find it correctly, that p-value is 3. And ultimately, with all this put together, what we learned on the front is that the parabola would have to go in this direction. We would call this a vertical axis. That's because the parabola is opening vertically. Specifically, it's opening up, but this is going to be a vertical parabola, which allows us to choose the correct formula. And now we're starting to get into some of the nitty-gritty, the formula that uses the x being squared and then would equal 4p with the y minus k. So we're able to pick this formula, again, because we determined that this is a vertical parabola. Maybe you've been wondering, what's this 4 right here? Indeed, it is always there. We didn't really talk about why it's there. It's something that will kind of work out when we get to the last couple examples. But again, to be clear, it's always a 4p. So when we start filling some numbers in here, like filling in the vertex, I hope that you're going to fill in a 0 for h. You can also fill in a 3 for p, and keep the 4 there. Okay, so it's 4 times 3. And then, of course, you can fill in the other part of your vertex. You can fill in the 2 for k. Now, if you're wondering, well, what's my final answer? Oops, I forgot my square. That's really important. So what's my final answer? Well, my final answer is going to be x squared equaling 12 y minus 2. And in fact, that is a conic section. That's standard form for a conic section, so that is completely appropriate as my final answer. You think you might be catching on? Do you think you can write an equation for a parabola that has a vertex at 3, 0 and a focus at negative 1, 0? Honestly, if we were in class, this would be a time where I would encourage you to try this problem on your own. So push pause on the video, make a sketch, and see if you can fill in to the correct formula. I wish I could see what you did, but I bet I wouldn't be surprised to see that you graph the vertex at 3, 0 and a focus at negative 1, 0. Now, be careful. You do want to get these in the right place. Sometimes students accidentally kind of put them backwards. You know, the directrix is always on the outside or the other side of the vertex. So when we think about drawing the parabola, we would definitely have to be drawing it opening to the left. So some conclusions you would make here is that this is a horizontal parabola opening to the left, which basically allows me to use the y squared formula. Remember, when y is squared, that's going to be a horizontal parabola. And it really is just now time to fill in some numbers. I suppose one other number, which actually might be one of the most important numbers, is that you determine that p equaled 4. Or did you? You actually should have determined that p would have equaled negative 4. This is a little detail for this problem. The parabola is opening to the left, so the p-value has to be negative. So when we get to the business of filling in, you would fill in your vertex, of course, for k, and also for h. Of course, we're going to fill in a negative 4 here for p, and finish off with my x minus 3 here for the rest of this formula. So your final answer is going to look like y squared, and that equals negative 16 x minus 3. That's standard form. That is an appropriate way to write the answer for a conic section parabola that is opening to the left. All right, are you ready to move over to the other column where we're going to actually define the vertex, focus, and directrix? And you'll notice that, of course, we're given the equation. Now, I'd be curious what you're already noticing when you're given the equation in class. I wouldn't be surprised if I'd have some students say that they already know what the vertex is. That's great because the vertex is really just h and k. Just be careful that you're using that opposite concept. So of course it's -1 but +2. So that was pretty quick. We got our vertex. What about this number? What about the p-value? Is it true that p equals 4? Does p equal 4? Well, it's true that p has to do with 4, right? But isn't it really the case that the number that's in this equation really represents 4p? What that technically means is that 4p equals 4, which of course would allow you to say that p equals 1. So be careful as you analyze for the p-value that you always use that 4p idea, which we will again discuss a little bit at the end of the lesson. Now, when it comes to coming up with the rest of this analysis, a graph is definitely needed. But before we think about the graph, we do have to notice one more thing, and I hope that that it's not a small thing that you notice that the exponent, the square, is on the y. And if y is being squared, this is definitely going to be a horizontal axis. It's going to be a horizontal parabola. And further, because the p-value is positive, we're actually able now to say that this graph is going to open specifically to the right. So we have a horizontal parabola, it opens to the right. I think we're ready to think about a sketch so that we can finish up the rest of this problem. Now, you want to graph the vertex correctly and carefully. Of course, it's at -1, 2. The p-value, remember, was 1, and so that means that the distance to the focus is only 1 away from my vertex. So I'm able to locate that. I would say visually I'm able to locate that to be at 0, 2. Because again, this distance right here was, let me make that a little better. This distance right here was only 1, which also allows me to go backwards to the directrix 1 unit. And if I go backwards, again, 1 unit, I'm going to be able to make a conclusion visually that my directrix is at -2. And so these are the things that I want to be coming up with. But I also want to be thinking about the graph that's going to have to fit nicely between this focus and directrix. But now I would have a complete analysis of this problem. But just notice again, the directrix was given as an equation. Don't give the directrix as a point. Of course, the focus and the vertex were given as points. Are you ready to try one on your own? Okay, it's a great time to pause the video, see if you can analyze this equation, and I'll meet you back here in a moment. All right, how did you do? I find that students will find the different parts of these answers in any order, but it really is true that before you do anything, you have to make sure the equation's in standard form. So have you noticed that the squared variable and the non-squared variable, they always need to be separated. So before we do anything else with this problem, you have to write this equation in standard form. You have to subtract the 8 y minus 2 quantity and terms over to the other side. Now, you could do all kinds of things. You could identify the p-value. The p-value, of course, very carefully being -2. You also could have identified early on that since this is an x-squared parabola, that we're talking about a vertical a vertical parabola. But now that I know that p is negative, I can even say that it's going to be going down. People come up with the vertex. I hope that you did, because the vertex is really given to you with h and k, so we can identify that to be at -4, 2. At some point, we got to go over here to the sketch. We got to start to put these numbers into more of a visual. And so here's our vertex, -4, 2. And now we can get the p-value involved. The p-value of -2 is going to actually force me to move down to my focus. I can even now identify that focus to be at -4, 0. Most of that was done visually just because I went down 2. I'm still, of course, at -4. So we have the focus, and we can even kind of go backwards here, back up to the directrix, because we know that that's going to have to be on the outside of this parabola, which you certainly can draw whenever you're ready, but I'm going to label this directrix as y equals negative, as y equals positive 4 because I moved 2 units the other direction. Draw your parabola, and everything is in its place. Now, it might be nice here, especially when it comes like a test or quiz, to actually list these answers, although I am recopying them to have them listed in one nice place. So I encourage you to do that when you're doing your homework. On a quiz, I actually will give you a space to. All right, so let's look at a equation that's not in standard form. How about something like this? Y squared minus 4y minus 20x plus 24 equals 0. Clearly, it's not in standard form, but we can put it in standard form. And so a couple things I want to draw your attention to is that whatever variable is being squared, that's kind of the king. The one that's being squared is the one that gets to stay by itself. It gets to stay on that side of the equation. That means that the non-squared terms plus the constant term are going to end up needing to be moved to the other side. Now, the reason I'm doing this is because I'm trying to get this equation prepped for some alterations, and that main alteration is that we're going to complete the square. You see, with the squared term, it really wants to be completed if I just add the right number. And now remember, that number 4 is half of negative 4 squared. Now if I add 4, I have to add it to both sides of the equation. But the nice thing is that as soon as I add 4, this equation is able to be written in a more standard, a more factored, see how that looks, form. Now, of course, over here, if you add negative 24 and 4, you're going to end up with negative 20. I'm going to kind of just think of that as negative 20, because what I also want to do is make this side look a little bit more standard. That is, I want to factor out a 20. And if you factor out 20, you're left with x minus 1. So all of a sudden, my equation, when it just becomes factored, is looking a lot more standard. And I think the idea I had with this problem is that then I can very quickly grab the vertex, of course the vertex being at 1, 2, and we can also deduce the p-value. Now don't say that the p-value is 20. Of course, do say that 4p equals 20, so I'm able to get my p-value even here to be 5. And I'm not really sure why I have this arrow pointing this way. Maybe we should actually point it this way, because it looks like that information, at least we want to show you how that information matches up with what's given over here. So let's just graph the problem. There's always a graph that is involved with these problems. That's the idea, to help you guys kind of get everything where it should be. So here's our vertex. And, we should have deduced also that since this was a y-squared problem, that we were going to end up with a horizontal parabola. And of course, since the p-value is positive, a horizontal parabola opening to the right. So when I get back over here to my graph, I'm going to want to move to the right 5 units to get my focus. And so as it already says here, the focus ends up being at 6, 2, but I wanted you to see how the number 5 kind of affirms that. The only other thing to do here is to get a directrix on. Your directrix, we know that it's also 5 units. It's just going to be 5 units the other way. Make sure you're going 5 units from x, so that should get us at negative 4. And if we draw the parabola, it indeed is a parabola that opens to the right and matches with that equation. All right, so we completed the square. All right, let's flip back over to the front. We're going to look at just a few more examples that you're going to find out are actually kind of like your homework. And they also fit what we just finished, that is talking about problems that are not in standard form. So how about an equation like y equals negative 2x squared. The funny thing about this equation is that it's actually kind of a simple one from your Algebra 2 class. So why can't we just do the problem in this form? Well, as you'll discover, the reason we can't do it is because we can't get the p-value. You need the equation to be in standard form, that is, in the conic section standard form. Now, remember what I said on the other side of the paper? Whatever is the squared variable is king, so it gets to be by itself. That means that this negative 2, I know it doesn't seem like it's a big deal, but that negative 2 needs to be on the other side. So, of course, when we divide by negative 2, we're able to start to get this equation ready again for standard form. Now, there's some things I'm going to show you here that you wouldn't necessarily have to do, but it does help you in order to see that I also then can conclude that there is a 0 that's being subtracted with y. In the same manner, I can conclude that there's a 0 being subtracted with my x squared. In doing that, it helps me now to see for sure what's up with all the features of my parabola. And maybe the vertex is the first thing that you would see here. It definitely has a vertex of 00. Honestly, the main thing I want you to see is how we now will use negative 1/2 in order to find our p-value. Now be careful, 4p is still equal to that coefficient. So that means when you divide by 4, that, yep, you actually get negative 1/8. And negative 1/8 being our p-value is going to help us to be able to finish this problem for the focus and the directrix. Now, at some point, we probably need to think about the shape of this parabola. It does have a vertex at 00, but it more importantly has a x that's being squared, which means that it's a vertical parabola. So it's either going to open up or down, right? It's going to open down because we have a negative p-value. So I like to draw my parabola opening down from this vertex so that I can be sure that my focus is going to end up inside. And now that I know that my p-value is negative 1/8, I can just move down. I know it's a weird increment, but I can move down negative 1/8 and deduce my focus to be at 0, negative 1/8. In fact, I can move backwards. I can move up in order to deduce that my directrix is going to be at positive 1/8. And so we take a problem that was actually in a form that looked a lot more like something from algebra class, and we were able to still put it into standard form so that we can come up with our features. Let's do another one like this. I just know that students often have questions. This is actually a lot like the first few problems in your homework. The funny thing is that the equations are actually more basic, and sometimes that can make them more complicated. So here's an equation that clearly is not in standard form. We can see the squared variable. It needs to park itself. I'm going to move it on the other side because that helps me to get rid of course, anything that's negative. If I want, I can certainly think of this as x minus 0. I can also think of it as y minus 0 squared. But I think that the key to this problem is that you realize that the p-value is the value that's in front of the non-squared term. And what I really meant is the 4p value is in front of that non-squared term. So 4p would have to equal 1. And if 4p is equal to 1, then we can deduce that p equals a fourth. Again, it's a fraction, but that's fine. If I was going to finish this problem, which I think we should do, I would at some point conclude that this problem is horizontal. It's horizontal because, of course, we have a y that's being squared. And since the p-value is positive, it's going to be a horizontal parabola opening to the right. I can draw that parabola opening to the right now because I already know that the vertex is at 0, 0. I mean, we should have concluded that. But I'm just trying to help you see that now I'm able to say that the focus is on the inside of this parabola, of course, moving 1/4 to the right. If I move 1/4 to the right, I'd have to be at the point 1/4, 0. And then my directrix is going to move back the other way, that is to the left, so I can write that as x equals -1/4. I want you to see how we do the problem visually in order to come up with my focus, my directrix. Now, I want to do one more problem with you, but it looks like that I've conveniently kind of run out of space. So I'm going to give myself a little bit of space here, and you can squeeze it in if you're just taking notes on your own paper. Again, I have one more problem that I want to put in here. Let's add some space here for me to do this, and I want you to be able to write an equation from a graph. I want you to be able to write an equation from a graph. Now, this is going to also happen in your homework. You'll notice that they draw the parabola. They also give you a point. Don't worry about exactly where I got the point. I'm just making up the example. We would be able to deduce from this problem that the vertex said 0, 0. And that's kind of where I'm going to start with writing this equation. Actually, I think that where I really want to start is noticing that this problem is definitely vertical and it's opening up. So in that case, I'm going to be able to use the x squared equation. But noticing here that we can start to fill in some of the information that we have. I mean, I can fill in my vertex to be at 0, 0. And, now we need to find the p-value. Well, how am I going to find p? Using this point? Yes, using the point that you're going to plug in for x and y. So I'll be able to, of course, conclude that this equation is really nothing more than x squared equals 4py. But now I can plug in 6 for x, and I can plug in 12 for y. And we have ourselves an equation that we can solve for p. It looks like that the equation eventually becomes 36 equaling 48p, which would give me a p-value of 3/4. Now, when it comes to writing our final answer, you want to write your final answer in standard form. I've kind of been creating my standard form equation up here, and the only thing that it's really missing is my p-value. So let me fill in the p-value in this space, and we'll get that 3/4 conveniently plugged in. But I want you to see something. I want you to see how these 4's cancel out, which actually leaves me with an equation that's going to have a coefficient of just 3. So looks like I'm still running out of space. I got some space problems here. But my final equation is going to be x squared. Where can I put this? It's going to be x squared equals just 3y. Again, because the 4's canceled out, and my vertex at 0, 0, I'll end up with just x squared equals 3y. All right. You're ready to start your homework. Had we been in class, you would have a chance to start working on this in class, which means that you might have some questions. And I'm here to help you. You'll have to reach out. You can certainly network with your classmates, but you want to do this assignment in a manner that you expect it to be turned in, which it will be, and graded. It will be graded for correctness, kind of like your calculus class next year, where when you're actually working out your assignment, you're not just doing it to complete it, but you're doing it to learn, and you're also doing it for a grade. So do a great job with it. Keep it organized, and I look forward to getting your completed work on the next day.